Okay, now we'll be explaining 4 different time series models. Okay, it's a purely time series model. One, what you call moving average model. The other one is auto-regressive model, auto-regressive moving average model, and auto-regressive moving integrated average model. Okay, so we'll first start with the auto-regressive model. So the value at t for a series, so this is my model prediction value, is actually a combination of all the previous values and their associated parameters, and then we have an epsilon t. So this is the error of this fitting. Okay, so you can actually explain this as a regression formulation, but if you pay attention, it's regressing itself. Okay, the predicted value of x at time t is a regression setup by using its corresponding value. Okay, the auto regressive model has p parameters. Okay, the p is how many timestamps you want to go back. Usually we call these as lags. So we are actually using p lagged values of x to actually model what will be the next prediction values. Okay, the moving average has its own parameter q. Here actually we are modeling the error at time t minus I. Okay, so here we are predicted value at time t is actually the average of this series historically plus the q error terms we are fitting here with their corresponding parameter denoted as theta. Auto-regression model has its number of parameter p, and then moving average has its q number of parameters. This defines our auto-regressive moving average model. So auto-regressive moving average model has a p plus q number of parameters, and p is the auto-regression part and the q is the moving average part. Okay, so this is why we call it as auto-regressive moving average model. Okay, so auto-regression moving average, then there is a term coming what is called integrated. Okay, so here p is the number of lags and q is the number of lags of the error term, and there is an in between process what you call degree of differencing. Okay? So you have p number of parameters for your auto-regression process, q number of parameters for your moving average process, and then how many times you want to differentiate to make non-stationary model stationary. So this is a very popular ARIMA model, and I think you guys have now understood what are these p, q, and d parameters are. Okay, through this notebook we'll be presenting how we'll do a time series model using the ARIMA model. So we are loading the ARIMA model from one very popular Python package, what you call a stats model. So let's load the packages. Here we are loading the data, and here we plot the data. Okay, so you can clearly see that the data is quite old, starting from 1901 to some months of 1903. So quite old data set. The y-axis is actually the number of cells. So you can clearly see that there are some seasonal pattern, and there are some trend displayed through this data set. Okay, first just showing the autocorrelation plot that we were discussing. So here clearly you can see that this signal is actually a non-stationary signal, and here we are fitting an ARIMA model with p equal to 5, q equal to 3, and d equal to 1. So p is the number of timestamps, the number of lags that your auto regression model will work on, and then q is the number of lags moving average model will work on, and how many time you want to differentiate to convert the non-stationary signal to stationary. Okay, so that's how I read. And when we call ARIMA, then you are passing your data as a parameter, and then what order you want to fit your ARIMA model on. Okay, and then as soon as you fit, you will see that how the model is actually fitting. And here you can clearly see that the blue curve is the original data, and then the red curve is the model fit. So we can clearly see that the model was able to catch the trend and also some part of the seasonality. But one thing we are missing, that the model is not able to catch the scale. Okay, again, this is purely a time series model, what we call auto regressive moving average. So I'll share this notebook, you guys can play with that, and let me know if you have any questions.